Hi, I'm David with Portrait Displays, and in this video, we're going to calibrate the Samsung QN55S95C AF-XZA. We're running firmware 2020 and using CalMan Home for Samsung, the G1 pattern source, and the C6 HDR5000 colorimeter. Let's get started. I'm going to come over to my computer running CalMan Home. I'm going to double-click the CalMan Home icon. We're now brought to the CalMan introduction workflow. If this is the first time you're using CalMan, I encourage you to use the workflow to get familiar with the controls and setting. For the purpose of this demo, we're going to come up to the top left corner here where it says CalMan, select the menu, come down to Open Workflow Template, select Display Specific, and choose Samsung AutoCal. With the Samsung AutoCal workflow loaded, we now have an option to choose whether we want to calibrate SDR or HDR. Let's select SDR and press Next here in the bottom right-hand corner. On this page, we're asked to do a session setup. Here, we're going to want to connect to our meter so we can measure the display and our pattern source so we can generate a pattern to measure. Let's come over here to step 1 and press Find Meter. Now I'm using the Portrait Displays C6 HDR5000. CalMan's going to automatically search, find the probe, and connect. You can tell it's connected here in the top right corner where you see it says Portrait Displays C6 HDR5000. Our next step is going to be to come over here and choose our meter mode. You'll notice that I'm set to OLED TV 2022 RGB. The last time I used this probe, I was using that meter mode. But since this is a QD OLED, I'm going to want to select the meter mode that matches my display. Let's select the modes, and you can see all the modes available currently in this list here. Let's find the one that closely matches the Samsung QD OLED. As I scroll down, I find the meter mode for the Quantum Dot OLED 2023. Because this is a 2023 model and it's a Quantum Dot OLED, I'm going to select it. Next, we'll want to connect to our pattern source. Today, I'm using the Portrait Displays G1. Let's press Find Source. Here, I'll want to select the manufacturer as Portrait Displays, and I'll select the G1 as the model. Now, my network doesn't have auto discovery enabled currently, so I'm going to use the IP address that's on the screensaver on the G1. As you can see, it's floating across the screen. We'll type this in 10.23.10.215 and press Connect. You'll notice the pattern source window open on the right. Here, we're going to want to set the settings of the pattern source to optimize for the display. Our workflow currently advises to set the delay to 2 seconds and to use a full field window pattern. I'm going to set CalMan to that now. Window size, full 100%, delay 2 seconds. Our next step here is to choose our calibration targets. CalMan is defaulted to the BT709 standard with a gamma formula of BT1886 and a D65 white point. If you wish to change these, you can do so here. For now, I'm going to leave them and I'm going to press Next. On this page, we're now at our pre-calibration measurements. But if I take a look over at my G1 pattern source, I can see that the alignment pattern shows that my C6 isn't quite perfectly aligned on the screen. I'm going to take this moment to realign my C6 and get it as close to center as possible. The probe is now near center. It's flush with the screen. Let's get back to our pre-calibration readings. I'm going to come over to CalMan in the bottom right corner here and hit Read Series. CalMan's now going to put a pattern, take a reading, and plot the data against the target. Okay, our pre-calibration measurements have completed. If we look at our RGB balance, we'd really like this to track along that 100 line. So our EOTF is not quite tracking where we'd like it to be. We also have the display going plus blue. The color gamut seems to be mapping in a much wider color space than it is for the target of BT709, and our delta E's are showing is fairly high here. Now, it's important to note, I just took this out of the box. I haven't touched anything. I haven't turned off any energy saving or anything with the display. I took it out of the box, I updated the display, and we started the video. Let's press Next and move on to the next step. We're now on the stage to connect to the Samsung TV. You may remember we connected to the C6 HDR5000 as our meter, we connected to the Portrait Displays G1 as our pattern source, but now CalMan needs to connect to the display so it can control the settings of the display and perform the calibration. There are a couple ways you can do this. Today, I'm going to use the network control, but if you look in the top right corner, you can also connect to a large number of Samsung displays over a serial connection. That does require an adapter, and you can contact our support or check our knowledge base for more information regarding that. I'm going to select the network and I'm going to press Find Samsung TV. You'll notice the manufacturer is already set as Samsung, but I need to select the model. I'm going to choose model and I'm going to come down to IP 2023 QLED QD-OLED. Now I'm prompted to enter an IP address. In order to find that, I'm going to pick up the remote and hit the gear icon. Press the center button on the gear, press the center button on all settings, arrow down to connection, right arrow over to device name, select network, and then choose network status. We'll arrow over to IP settings, and now we have the IP address 10.23.10.201. 10.23.10.201. With the IP address entered, let's press connect. Now you'll notice a pop-up in the top right asking for permission for CalMan to connect to the display. We'll press the center button to allow it, and CalMan has now connected to the display. If you're having trouble connecting to your display, take your remote, hit the back arrow, back out again, come down to Expert Settings. There is a setting on Samsung displays that sometimes is turned off with certain models when it ships. That's your IP remote. If the IP remote is not enabled, enable it in order for CalMan to connect. This display happened to have it enabled out of the box. Let's return back out of the menu, and let's come back over to CalMan. You'll notice on the left side of the screen, we have an option for movie. If you click on that list, you'll see all the picture modes that CalMan's able to address. Right now, I'm in the movie mode. I'm going to leave it in the movie mode for the purpose of this demo. After I've selected the mode, let's press Full DDC Reset. The Full DDC Reset is going to baseline the settings in the display to get it in a known state for CalMan to start the calibration process. With the reset completed, let's come down to the bottom right and press Next. At this stage, we're prompted to set the luminance of the display. Now I'm targeting BT709, so I'm going to target 100 nits, or 100 candelas per meter squared. But if you're in a bright environment like we are in the studio, you may want to target a higher number such as 150, maybe even 200 nits. It's important that you come up with the target that you'd like to achieve and then set that here. Let's press Measure Luminance and see where we're measuring right now. Okay, under peak luminance we're measuring about 149 nits. So I'm going to come up here to the brightness, and I'm going to turn that down to get that closer to 100. You don't have to be perfect here, because as you go through the calibration process, you may gain or lose a little bit of light depending on the state of your display. So I'm going to target just over 100 nits. It looks like at 21 I'm at about 106, and if I come down to 20, I drop down to 99. I'll target 106 just in case I lose a little bit of light, and we'll readdress this later in the workflow. Let's press Stop, and now press Next. Now we're at the Grayscale 2-point portion of the workflow. I'm going to come down to the bottom right and I'm going to press AutoCal. The AutoCal setup window is going to come up. You'll notice the active Grayscale points are set to do a 2-point at 20%, 100% with a delta E target of 0.5. I'm going to leave those there. You can of course experiment with these if you'd like to change them, but let's press OK and CalMan will walk through the 2-point calibration process. Okay, our 2-point grayscale is finished. It took 1 minute and 56 seconds with a total of 20 reads. We're going to press OK, and let's move on to the next step by pressing Next in the bottom right-hand corner. We're now at the Grayscale multi-point portion of the workflow. Let's come down to the bottom right, press AutoCal. The AutoCal setup window comes up, and now we have our active grayscale points set to SDR, and we have our delta E target set to 0.5. Let's press OK. Okay, while the multi-point calibration process runs, let's discuss a little bit about what's happening. Let's get out our trusty whiteboard. Okay, with our whiteboard, let's create one of our EOTF charts you'll see in the workflow. I'm going to take our X and Y axis, and we're going to put our yellow target line. So this is our target line. Now, as we measure the multi-point, we might do a grayscale sweep and find that we might be going, let's say, here. And I'm just making this up, so bear with me. Now, in a system where we have a 1D lookup table, CalMan can take a bunch of measurements, and then it can say, okay, I'm taking a measurement, and then it can say, okay, I know where these points are, I know where the curve needs to happen, I'm going to calculate all these points in between to make my response curve. We start from scratch and we do all the work on our side. But in a multi-point system such as on the Samsung, what we actually do is we select the points they give us, maybe 100, 90, 80, 70, and we adjust these points, and then Samsung interpolates what's in between. So it's sort of like both systems almost have their own 1D lookup table, except instead of us doing all the math for the lookup table, Samsung's doing the math for the lookup table, and we're just able to adjust these points. Now, the plus side of having something like this is it can often go a little bit quicker, and you can only adjust the same points. So it's a very, very straightforward system to adjust. You can even do this manually if you didn't want to use AutoCal. Of course, AutoCal takes all the guesswork out of it and makes it seamless and easy. Now, with a 1D lookup table, we can actually put points wherever we want. So let's say we had a curve coming out of black a little bit slow, and then it kind of comes into that target line. But if I only have a point in a multi-point system here and here, I might not be able to get this response curve to come into target there. So a multi-point system kind of limits where I can adjust the display. Now, if the points happen to line up and the points interpolate well, you can get virtually the same results with a multi-point system as a 1D LUT. As a panel ages and a display starts to drift, it becomes more beneficial to have that 1D LUT because we can start, again, seeing where that has drifted over the years, and we can start to really bring that back in. So that's the difference between what's happening with the multi-point and the 1D LUT. Let's take a look at how CalMan's doing with the multi-point correction process. Let's put our trusty whiteboard back, and we'll step back over to CalMan. Okay, CalMan has finished the calibration of the multi-point grayscale. It took 6 minutes and 16 seconds and a total of 68 reads. Let's press OK and take a look at our results. Here you can see our RGB balance is tracking really nicely with the red, green, and blue right on top of each other. If we look at that same chart with the luminance value, you'll see we have a little bit of a dip here near black. And if we look over at the EOTF chart, it does look like we come out of black a little bit slow, and then we come back in. Now, once again, that could be because of where the points are and where the response is. It could also be that it's trying to correct for a lot of this very bright ambient light that's in the studio. There is a lot of light. It is shining on here. It is near black, so maybe the probe was getting some erroneous readings where it was measuring a little bit of light. But if we do take a look at our Delta E 2000 charts, you'll notice those Delta E's are still very, very low across the board. And you'll also see that on our luminance chart, we are tracking that target line. So let's leave this here and let's move on to that next step. But there's a couple things we should talk about. You may notice in the workflow, there's this CMS adjustment here at the top. That's the color management system adjustment. What this does is adjust the color space or the color gamut mapping to hit the target. There's a couple ways you can approach the Samsung. One is you can select the CMS adjustment and you can perform the color management system adjustment via AutoCal, or you can use the built-in tables. Let's take a look at what might be happening so you can make your own decision as to how you want to approach this process. We're going to pull over our whiteboard, and please forgive my chicken scratch. I do the best that I can. All right, so let's take an X and Y chart, and I'm going to make a really poor CIE diagram. So we're going to go over, we're going to come up, and we're going to kind of come over and come back down. All right, now let's choose some points for BT709. So we'll say this is BT709. Now, when you're adjusting color on a display, you have millions of colors in here in BT709. And we're only picking a couple colors to adjust. So we might pick a 75% blue, a 75% red, a 75% green. Maybe we even have yellow, cyan, and magenta. So we'll put some dots in here, and then we can adjust these points. Maybe you have 50%. So maybe it's something a little closer to the middle here. Maybe you're not even adjusting that far out. Right? So it's important that when you're adjusting this, you pick the point that matches where the image processing lines up. Now, we're only adjusting one point here. So just like our multi-point grayscale system, this one point of correction has to then scale out to all these other colors in that region. This one point has to scale out to all these other colors in the region. This one as well, right? So what ends up happening is you can focus on getting this one point really, really right, but you might have messed up these other points along here, or you might have messed up these points along here, or, you know, over here. So what I like to do is I actually like to look at what the system's doing, because we don't watch one specific color when we watch displays. We're actually watching content that's motion pictures. It's moving around. There's lots of colors. There's millions of colors. And so we don't want to obsess too much over this one specific thing and then sacrifice everything around it and have less accuracy. And so let's take a look at where we're at before we do the CMS adjustment. And then what we might do is we might actually walk through the CMS adjustment and see if it got better. So I'm going to come back to CalMan, and instead of doing this color space adjustment, I'm going to press next in the bottom right corner. And I'm now at my dynamic range page, but I don't really need to measure dynamic range here. What I want to do is I want to measure my peak luminance. Remember, we corrected our white point and adjusted our EOTF in the AutoCal process, so my luminance may have shifted as I did that. So I'm actually going to come down here, select 100 for 100% white, and then I'm going to come over here in the bottom right, and I'm going to press read single. Okay, so I'm measuring 103.8 nits, as you can see here, and I'm at 21 still. Let me take that down to 20 and measure again. We're at 96.7. That's a little bit below my target. So I'm going to come back up here, select 21, I'll measure it again, and I'm back at about 104. I'd rather be a little bit high than too low. So I'm going to leave it here, and I'm going to press next. We're now at the post-calibration verification portion of the workflow. Let's hit read series. And we're now going to go through that post-cal reading. Now remember, we haven't done our CMS adjustment yet. We basically did a 2-point grayscale and a multi-point with an EOTF correction, and we've optimized our luminance here in the movie mode. Let's see how this came out, and then we can go back and see what happens when we make a CMS adjustment. Okay, our post-calibration verification has completed. Let's take a quick look. Our RGB balance is tracking really nicely. We do have that little dip here on the bottom as we come out of black that we talked about throughout the workflow. Our Delta E2000 readings are pretty low. Our Delta E2000 on the color checker also very low. And if we look at these target boxes with the dots as the measurements, you can see just about everything is tracking really, really beautifully right now inside that CEIE. So let's look at this display performance. If we look at color performance, our average error is 1.2 and our max error is 2.4. Still very, very good. We didn't even do a CMS adjustment. Our grayscale performance has an average error of 0.4 with a max error of 0.8, well under that 1.1. Let's press next and compare that to our pre-calibration. Okay, so our pre-post calibration comparison. Now remember, pre-calibration, out of the box, didn't touch anything. 37.7 max delta E on the grayscale with an average of 22.3. If we come down to the post-calibration, we've got a max of 0.8 with an average of 0.4. Significant improvement on the grayscale EOTF. If we come over here to the color checker, you'll notice that I believe we were in a wide gamut mode, as you can see from the readings on the CIE diagram. Our max delta E was 32.8 with an average of 17.4. Now we're at a max of 2.4 with an average of 1.2. Significant improvement here. But let's take a moment and let's now do that CMS adjustment. I'm curious to see if we're going to be able to get better. So I'm going to come over to the left, I'm going to select this left sidebar, I'm going to select the color space portion of the workflow. Now you'll notice on the color space page there are some instructions here on the top. In order for CalMan to adjust the CMS, we need to be in the custom memory. Let's do this check before we proceed. I'm going to pick up the remote and hit the gear icon. Let's press the center button, press it again, come over to picture, arrow down to expert settings, and let's come all the way down to color space settings. And here we are in the custom mode. If you're not in the custom mode, make sure to set your display there before proceeding. I'm going to back out of the menu and let's come back over to CalMan. I'm going to press the AutoCal button down here in the bottom right. Currently, we're set for that saturation set at 75% with a saturation point of 75% and a stimulus level of 75. These are the values our engineers have worked with Samsung to determine are the best for this display. I'm going to keep them there and press OK. Okay, our CMS calibration is completed. It took 8 minutes and 23 seconds with a total of 89 reads. Now, if we come over here to the left side of the screen, you'll see red, green, blue, yellow, cyan, magenta. They're all in their target boxes and things are looking pretty nice. But let's come up here to the top left, select that arrow icon, and jump over to our post-calibration verification. Now, if we look at this post-calibration verification, this is the verification we took before we did the CMS adjustment. I'm going to come up here to the top, and I'm going to hit this little plus sign next to history 1. That's going to create a second history that I can do another post-calibration verification. Let's come down to the bottom right and press read series. Okay, let's take a look at our post-calibration verification. It looks like our grayscale performance is still at that average error of about 0.4 with a max delta E of about 0.9. Our average error on the color though has come down to 0.7 with a max error of 1.4. Let's see how that compares to before. We're going to come over to History 1 and let's take a look. So our average error was 1.2 with a max of 2.4 before. Our grayscale was at a 0.4 and a 0.8. So the grayscale went up by about 0.1. Now, we are in a bright room. There is meter tolerance, precision, repeatability issues, right, when you're making measurements over and over. So I'm not worried about that 0.1, but we did come down a noticeable amount on our color. So in this instance, the CMS on the Samsung actually improved the overall color gamut mapping when we measured the points on the color checker. Let's leave it like this and let's press next. Now these pre and post measurements are still the pre and post measurements from before, since I made a History 2 on the previous page. But you'll notice in the bottom right hand corner the Calibrate HDR. Right now we've calibrated the SDR memory on the Samsung. But if we want to calibrate for HDR content, we're going to click this bottom right hand corner button, Calibrate HDR. Now the workflow takes you back to session setup, but you know what? I actually want to hit this back button and I want to go all the way back to the welcome page. I'm going to go to the welcome page because you notice that when HDR is selected on the welcome page, we can actually select our year for the 2023 model QD OLED, and we're going to select the S95C. So let's select the S95C. What this is going to do is it's going to optimize the points of adjustment for calibrating the HDR mode on the display. So now let's press next and come over to session setup. Now, we don't have to go through step 1 again because we're already connected to our C6 HDR5000, but we are going to have to make some changes to our pattern source. You'll notice for SDR, we were in full 100%. We're now going to want to put in HDR at a window at 10%. So let's come back to CalMan and let's go all the way up to this Portrait Displays G1 under the Source tab. We'll come over to window size. We're going to now change that to window 10%. We're going to come down to HDR and we're going to turn it to HDR 10. With the generator now set up, we can come down to our calibration targets. You'll notice that CalMan's very intelligent and it's already populated the HDR targets for you. The color space is at Rec 2020, Gamma Formula ST2084, and the white point at D65. Let's press next. At this stage, CalMan wants us to do a pre-calibration measurement. Let's come back down to the right-hand corner and hit Read Series. Our pre-calibration measurements have completed, and as we can see, we do have a little curve here in the EOTF, but our balance looks okay. Now, we are zoomed out because of that curve, so it might be a little bit deceiving. If we look at our delta E's, we are noticing that some of those are getting a little bit up there. We don't really know if that's the tone curve or the balance at this point, but we'll get to that as we work through the workflow. If we look down the bottom left, you'll notice the delta E2000 for the color gamut is a little bit higher than we'd probably like. However, we are not too far off from those color targets. So what I'm probably going to infer here is that our luminance values aren't quite tracking the PQ curve right where we want them to be. So let's press next and move on to the next page. Here, we'll want to connect to the Samsung display. Of course, we're already connected to the Samsung display. So what I'd like to do is I'd like to choose the Movie HDR mode, since I'm going to calibrate for HDR. I'm going to hit HDR mode reset and press full DDC reset. Next, you'll notice in the workflow that it says you should use the OSD and change the HDR tone mapping setting to static. It also suggests that we make sure our color gamut mapping is changed from DCI-P3 to BT2020. So let's pick up our remote and let's press that gear icon. Let's press the gear icon again, press for all settings, select picture, come down to expert settings, and now let's go through and check our tone mapping. HDR tone mapping is currently set to active. We're going to change that to static. We're going to further arrow down and come down to our color space settings. They're currently in custom, but let's select that. You'll notice the color gamut is now in DCI-P3. Let's change that to BT2020. I'm going to now hit the back arrow and come out of the menu. And let's come back over here to CalMan and let's press next. We're now at the grayscale 2-point section of the workflow. Let's come back to CalMan and hit the auto cal button. We're now going to hit OK at 2 points, 30 and 80%. CalMan's going to put up that pattern, take a reading, and perform the correction. Okay, our auto calibration is completed successfully. The time took 1 minute and 44 seconds, and the total reads 24. Let's press OK and move on to the next stage of the workflow. Here we're at our grayscale multi-point portion of the workflow. I'm going to hit the AutoCal button in the bottom right, and you're going to notice the active grayscale points are already selected at HDR 20.B. That's automatically selected because this is in our database and you set up the mode at the start of the workflow. If you don't get the ideal results using the points automatically selected, hit reset and try the other set of points. We have as many displays in our database as possible, but it doesn't cover the entire breadth of displays globally. So it's important that you note how the results are coming out and adapt accordingly. Here, we're going to press OK, and Calman's now going to go through its multi-point grayscale process in HDR mode. Okay, our auto calibration process is completed in 22 minutes and 10 seconds, and it took about 189 reads. Let's press OK and take a look. Our grayscale looks like it's coming really nice here on the RGB balance chart, and our EOTF looks like it's tracking fairly well. As we come over here to the left side, you can see the gray line following that yellow line comes just a little bit down here and a little bit of a dip, and then falls right back in line with that PQ curve. Let's press next and move on to the post-calibration verification stage. Let's now hit read series. We're now taking a post-calibration reading to see how it came out. You may notice we haven't done the CMS. Let's see how this comes out and go back to the CMS just like we did with SDR. Okay, our post-calibration verification is finished. It does look like we're tracking that EOTF pretty well, but then as we get up to about that clipping point here in the grayscale in the EOTF, we are seeing a little bit of color fringing here. Our deltas still look fairly low, but we do have a max error on the grayscale of about 2.7. Now, I could probably tweak my pattern insertion a little bit and maybe manage that heating and cooling to get this a little better. I could also just have an error because I do have a lot of light in here. That light is shining on the screen. It could contaminate the reading a little bit and shift that white point just a little bit in that auto correction. Either way, we're still pretty good. I don't want to go back through the workflow and tune that at the moment, but let's take a look at our post-calibration verification with the color checker. So as we look at this color checker, we've got a max error of 2.8 with an average error of 1.3. Not terrible considering we're in HDR, we're in PQ. Remember, most displays can't fully do the color volume, but it does look like we might have some room for improvement here. Let's go back to the previous page and select the CMS adjustment. We're now going to select that CMS adjustment, and let's run through that CMS process like we did for SDR. I'm going to hit AutoCal in the bottom right. You'll notice we're at 50%, 50%, 50%. We're going to leave it there, and let's press OK. Okay, the full gamut calibration is completed successfully. It took 20 minutes and 37 seconds and 153 reads. So let's press OK. And if we look over here at the CIE chart, we do see that the red seems to be hitting that target, the yellow, the green is outside, the cyan hitting the target, blue, magenta. So let's see how this came out compared to our readings a few moments ago. Let's press next. Now I just did the post-calibration verification on History 2 because that's what we were on when we were doing SDR. So let's now switch back to History 1 and we'll now do a read series and see how this has come out after the CMS adjustment. Okay, our post-calibration verification is completed. Let's take a look at the results. Our grayscale performance has a max error of 2.7 with an average error of 1, and our color performance has now come down to a max error of 1.6 with an average error of 0.9. So let's take a look here on History 2 and compare that. Our color performance before we did the CMS was a 2.8 max with a 1.3. So in this case, running the CMS on the Samsung display once again improved the performance of HDR. I highly recommend you test your Samsung display to see what setting is best for you, with CMS adjustment or without. Now let's advance to the next page and we can look at those pre-calibration readings and those post-calibration readings with the CMS adjustment. So pre-calibration, we had a grayscale error of about 17.6 with an average of 5. Post-calibration, we have a max error of 2.7 with an average of 1. Much, much more improved. As we come over to the color checker here on the right, we'll see our max error is 15.3 before, 1.6 after, with a 10.2 average before, and a 0.9 after. So once again, we've noticeably improved the color gamut tracking of the Samsung display. There you have it. We hope you enjoyed the video. We'll see you on the next one.